Okay, we've already solved systems of equations using graphing techniques. Now I want to show you how slick it is to actually use algebra and not have to rely on graphs or the graphing calculator. Here's a fairly simple system of equations. We've got two equations. We've got the line y equals 4x, and we have 3x minus 2y equals 10. What we want to do is get it down to having one equation with one unknown, because we know how to solve that. That's just solving a system of solving a linear equation. So we need to find a way to get rid of a variable. And I want to point out to you that in equation number 1, it tells us that y equals 4x. So why should we use y at all? Instead of y, why don't we use 4x? So I'm going to take equation 1, and I'm going to say, this is communication issues here, sub 1. We're going to take equation 1 and sub it into equation 2. Now what that means is that I'm going to write equation 2 down again, except that since I know y equals 4x, instead of y, I'm going to write 4x. So 3x minus 2y, but instead of y, I'm going to put a set of brackets and write down 4x, and that's going to equal 10 from the second equation. So basically what I have here is 3x minus 2y, but from equation number 1 we know y is 4x, equals 10. So this is equation number 2. Now this is one equation with one unknown in it. So we have 3x, negative 2 times 4x is minus 8x, equals 10. And 3x minus 8x, when we put those together, these three positives cancel out 3 of those negative x's, and so I'm left with negative 5x equals 10. And now we'll divide both sides by negative 5, and I know that x equals negative 2. So I'm halfway done. I now know what the x point is. I just have to figure out what the y point is. Now to do that, I'm going to put it back in this equation 1, because this tells me that y equals 4 times x, so that should be pretty easy. And for communication, I'm going to say sub x equals negative 2 in, we're going to put it into equation 1. And that tells us that y equals 4 times, but we know what x is, so we're not going to put the x in. We're going to put in what we know x to be, which is negative 2. So y equals negative 8. So if I were to graph these two lines, they would intersect at the point negative 2, negative 8. So therefore, the solution is negative 2, negative 8. Now, that was fairly simple because we had a straightforward substitution in here. So let's get a different equation that's maybe a different set of equations that's maybe not quite so simple. Let's take 3x minus y equals 18. And that will be our equation number 1. And our equation number 2 will be 5x minus 4y equals 23 is our equation number 2. Now, we can still solve this by substitution. Even though I don't have just a straightforward y equals, I do have a y here that's almost by itself. It doesn't have a coefficient, or we can say it has a coefficient of negative 1, but there's no number in front of there, so that makes it very simple. So what I'm going to do is take equation number 1, which is 3x minus y equals 18, and I'm going to rearrange it to get y by itself. So I'm going to first subtract the 3x on both sides, which gives me negative y equals 18 minus 3x. And y isn't quite by itself yet, it's still got that negative there. So I'm going to divide both sides by negative 1, but I know all that does is switch the sign. So I have negative 18 plus 3x. I'm going to call this equation 3 so I can refer back to it easily. And I'm going to take my equation 3 and I'm going to sub it back into the equation that I did not use here. So I used number 1, so I'm going to sub equation 3 back into equation number 2. Now if I make a mistake and I sub this equation 3 back into equation 1, which is where it came from in the first place, everything's going to cancel out. So we have to be careful that we put it back into the equation that we did not use to rearrange in the first place. So for communication, I'm going to say sub equation 3 into equation 2, and that is going to be 5x minus 4 times y, but I'm going to put a big set of brackets because I solved for y up in this equation, equals 23. And I'm going to put in what I know y to be, which is negative 18 plus 3x. Now I have to use the distributive law to expand and simplify. So what that gives me is 5x and negative 4 times negative 18 is going to give me positive 72, and negative 4 times positive 3x is going to give me negative 12x. That's going to equal 23. 5x and negative 12x can combine and give me negative 7x. I still have this plus 72 equals 23. Now I want to subtract 72 on both sides. When I subtract 72 on both sides, that leaves me with just negative 7x on this side. And on this side it gives me negative 49. That's 23 subtract 72 is negative 49. And now to get rid of this negative 7x, I'm going to divide both sides by negative 7, which gives me x equals positive 7. So I have one of my variables solved for. Now to solve for the other variable, the y, I can sub this x equals 7 back into equation 1, equation 2, or equation 3. Now I'm going to be smart about where I sub that in though, because equation 3 has already been rearranged to get y by itself. And since it's y we're solving for, that's where I'm going to put it. I'm going to put this x in here, and y is all by itself, so all I have to do is the arithmetic on this side of the equation to figure out what y is. So I'm going to say sub x equals 7 in, we're going to put it back into equation 3, and that says y equals negative 18 plus 3 times x, which we know to be 7. So that's negative 18 plus 21 means that my y value is 3. So therefore, the solution is the point 7, 3. And that is solving by substitution.